Hi, in today's video, we're still in section 2.4. We're going to talk about two main theorems, remainder theorem and factor theorem. And this comes after talking about synthetic division. So in synthetic division, we talked about the resulting polynomial, the remainder we got, and how we can write it in polynomial form and in fraction form. So what we're going to do today is trying to find the remainder without dividing, and that's what we call remainder theorem. And the way this is done, it says use the remainder theorem to find the remainder when f of x is divided by x minus k. So x minus k is the divisor. And right here in the textbook problem, they gave us k nicely to be equal to 2. So first of all, what we're going to do, all what the remainder theorem tells you is plug into in f of x. So substitute x with 2. 2 multiplied by 2 squared minus a 3 multiplied by 2 plus 1. Remember PEMDAS, so exponent comes first. Minus 6 plus 1, which is 8 minus 6 plus 1. And that will result in a 3. So what is a 3? You need to understand what you got. So 3 is the remainder of which division? When we say the remainder, there's a division that happened of f of x divided by x minus k in general, but more specifically, it's here x minus 3, and that's the divisor. Because remember, that k, we get it by 0 of the divisor. So the way in the textbook, in this case, x minus 2, the remainder is a 3. The 0 of this divisor is k equals 2. And that's what we use to plug it in and find the remainder. This is the remainder. Now you could say, what's the purpose of finding the remainder without dividing? Why is the remainder that important? That's what we're going to see when we talk about factor theorem. But before I do so, I would like to show you the other method. So this is the remainder theorem. So when we ask you to find the remainder using the remainder theorem, this is what you must do. Now, if I tell you what is the remainder without specifically saying use the remainder theorem, of course you can do the synthetic division. You should know both. And then what we put on the outside is the 0 of the divisor, but in the textbook problem, they gave us the 0 of the divisor. Drop the first, multiply, add the coefficients, multiply again, add the coefficients, and this is actually true. We got 3 as a remainder of this division. Now the synthetic division gives us more because it tells us more specifically, so this was x squared, this was x, this was the constant, 2x plus 1 plus 3 over the x minus 2, which is the divisor. So this is what we call fraction form, the answer in fraction form. There is another way to write down the answer. It's quotient multiplied by the divisor plus the remainder, and that's what we call polynomial form. In this case, it will be 2x plus 1 because that's the quotient, the answer. We're going to multiply it by the divisor, which is x minus 2, and plus the remainder, which is 3. This is the idea of polynomial form is very simple. As if you're saying, going back to our example, 63 divided by 4. Yesterday, in the other video, we wrote it as a fraction form. It's 15 and 3/4. In polynomial form, if I were to write down the answer of this division, I would just say it's 15 times 4 plus 3. So the result of this division can show me, and I'm not going to show the fraction form here, I just need to know how I can write 63 as a product. So this is what we call polynomial form. Now, again, why is it useful to find just the remainder without dividing? So going back to the idea of remainder form, it is useful because it comes to an idea called factor theorem. And what does factor theorem means? The word factor should be very familiar. Now, we always used to factor a quadratic, but let's say we have x cubed minus 2x squared minus 5x plus 6, and we need to factor this. We're going to talk more about how to factor, but I'll tell you the factored form will be x minus 1, x plus 2, and I can't write here, x plus 2, and x minus 3. When I say factor theorem, it means I want to know whether I give you a number and it will be a factor of this polynomial. So let's take this example. When I see this, it says use the factor theorem to determine whether the first polynomial, so this one, is a factor of the second polynomial. So in other words, if I factor this and I have a product of factors, would x minus 1 be one of them, one of those factors? The way I would know, I will take the 0 of the divisor, I will plug it in the polynomial, and I will check the answer. 1 cubed is 1, 1 squared is 1, plus 1 minus 1. If the answer, so I just applied the remainder theorem. If the answer is 0, which is the remainder, so when the remainder is 0, then yes, x minus 1 is a factor of all the given polynomial, x cubed minus x squared plus x minus 1. If the remainder is not a 0, then it's not a factor. The divisor given is not a factor. So now I know that one of those factors is x minus 1. What I can do is I can go ahead and divide the polynomial by x minus 1 using synthetic division. And when I divide using synthetic division, we're going to end up with a quadratic. And we all know how to factor quadratic, whether using x method or any other method.